So yesterday we solved two problems on the multiple loads. Okay, in incline support. Incline support multiple loads, one incline load and incline support. Okay, so I hope this is clear to you. Solve. So I told you we have to make it a little bit more complicated. We started with friction. So what I will think is two more classes I will take on this simply supported beam, because 2-3 more different types of problems I have to tell. Then we will start with friction. Okay. So this is one problem which I have marked yesterday. So I think we can try to solve this. Okay. So basically, simply supported beam under. And there is some member like this. Member attached. And there is a load here. Okay, so how do you solve problems like this? In the problems I can solve it. Basically, if you remember, 3-4 class before, was aeroplane problem solving. This one. Okay, so these problems we are done. This load we were transferring this to this point. Here point transferring problems. Okay, so aeroplane so yeah. So what we will do is we will also try to transfer this load to this point. It is simpler for us. Okay, so in the problems, try to find the loads, equivalent load about this point normal so how do you so basically the idea is you have to remove this and replace the entire setup with a load. Okay, so in the question there will be one more thing, assuming all members are weightless. Okay, then a weight to active weight cancel weight assume. Okay, so my question is this is my arrangement. Here arrangement 2 meter, 0.5 meter, 10 kilometer. Okay, so this we have to transfer to some other point here. This point load transfer. So these two should be equivalent. Equivalent. Right? So that is the idea. So how do you do that? So this let this point be O dash. So this is O dash. Okay, so this is system 1. System 1, system 2. So this is system 1, system 2, but then just for understanding purpose I am doing this. So this is system 1. System 2. So either random should behave in the same way. All the summation of all the forces in x direction of both the systems should be matching. Either random same. Summation of all the forces in y direction, summation of moment about some point. Let's say O. Point is so I have to take O dash. Okay. So what is summation of force in x direction? Here system the x direction of force so it is. So this is right positive, this is up positive, this is anti-clockwise positive. Okay. This y direction force minus 10. Okay. This moment about O dash 10 into 2. So that is clockwise, so minus 20. Okay. This is in kilometer, this is kilometer meter. Okay. So here system in system 2 we will find the same thing. Summation of force in x direction. X direction we have some force. So let's say I'll mark those forces. Fx, Fy, M on M. I'll mark this as M. Okay. So Fx in the rainbow, it is right hand side, so it is plus. Summation of forces in y direction എന്ന് പറയുമ്പോൾ there is a Fi downward, so it's minus Fi. And summation of forces about o dash എന്ന് പറയുമ്പോൾ Fi into 0, Fs times 0, then minus m, clockwise to minus m. Okay, now what we will do, we will equate these forces. Okay, അതായത് fx is equal to 0. What we will get is fx is equal to 0. We will get fx is equal to 0. Fx is equal to 0. Minus Fy is equal to minus 10. So Fy equal to 10. And minus m equal to minus 20. So m equal to 20. Okay, this is kilonewton. This is kilonewton. So this I can replace as this entire system I can replace as a 10 kilonewton force downward and 20 kilonewton meter clockwise. But here the force moment I can replace it. So that means what I do, this entire setup will become simpler. This thing I can just do. അതിന്റെ equivalent force ഉണ്ട്. അപ്പോൾ ഇതിനു വേണ്ടിയാണ് നമ്മൾ ഈ ഫോഴ്സ് equivalent force നമ്മൾ കണ്ടുപിടിച്ചത്. ഇത് 10, there's a moment 20. Okay, so now it is simple. You just have to find the reactions for this problem. So there are 3 reactions that is possible. So this is A, this is B. So this is pain support. We have 2 reactions, VA, HA. This is a roller support. We can have only VP. Okay. So why? Because as pin support, and this is roller support. Okay. So we have VA, HA, and some movement, force movement. So this is a problem in which I hope this is clear. But in the problems we know how to tackle it. Okay. Now it is simple. What it is in equilibrium. Okay. So for it is in equilibrium. System is in equilibrium. So this means summation of forces in x direction should be 0. Summation of forces in y direction should be equal to 0. Summation of moment about any point should be equal to 0. Okay, these conditions should be satisfied. Okay, so first we will try to satisfy the first condition. So that is summation of forces in x direction equal to 0. Okay, what is x? So right is positive. Right is positive. Okay, so we have HA. Here HA, which is a plus. Then there is no horizontal force here. There is no horizontal force here. There is no horizontal force here. Equal to 0. So HA is 0. Okay. Now summation of all the forces in y direction equal to 0. Up we will consider as positive. Okay. So we have a VA here. So that is plus. We have a minus 10 here. Okay. There is a minus 10 here. So that's down. Then we have plus VB here. Equal to 0. So this means VA plus VB equal to 10. So this is another thing that we can use. Okay. And the last one is summation of moment about any point. About which point I will take? I can take this point. I can take this point. I can take this point. Any point I can take. I would let's say I will take moment about A. Should be equal to 0. Okay, moment about A no remember. So HA into 0. But I'm just explaining it. HA into 0, VA into 0. Okay. Then we'll come here 10. 10 into 2 clockwise. So it is minus. Okay. then this moment is also there. Appo moment about any point. Appo ee moment ennu parayumbol about this point, this point, this point, this point, this point, this point, ഏത് point ഈ plane എടുത്താലും moment will be 20. ഇതിന്റെ moment about any point in this will be 20. Okay, so that will be clockwise, so it is minus 20. Now why it is any point it is 20? So this I will explain. I couple of I will explain it again once more. Why if you are doubt about this point, any point, moment in the moment in the influence is same moment. So it is clockwise, so we have put the minus. Okay. Now what about VB? So VB into 3 plus 2, 5 plus 2, 7. It is anti-clockwise. So it should be plus. Z equal to 0. Right? Okay, now what is this? This is 0, this is 0. 10 into 2, 20. So minus 20, minus 20, plus 7 VP. Okay, so I hope I'm taking all those values correct. 3, 4, 5, 6, 7. 10 into 2. So this is just the stupid mistake I used to make. Minus 10 into 2. Okay, minus 20. VP into 7 is clockwise, so it is okay. So minus 20 here, minus 20 here, minus 40. Okay, so 7 VB equal to minus 40. VB equal to 40 by, sorry, minus 11 plus. Minus 40, right? Plus 40 by 7. Okay, so what is 40 by 7? 5.7 kilometer. Okay, now what is, if I substitute VB here, what I'll get is VA plus 5.71 equal to 10. So VA equal to 10 minus 5.7, 4.28. Okay, so we have got the answer, all the answers. Now we just have to draw the final diagram. Okay, so what I'll do, let's copy this. So we have HA 0, 0. We have VAS 4.29 upward. And we have VBS 5.71 upward. Okay, so these are the reaction. Reaction. So this is 0 kilometer. HA, VA, V. Right. So I hope it is clear to you. Okay, assumption. Okay, I told you about why moment about this point is moment at the 0. Okay, so that we'll just discuss quickly so that doubts are removed. So why moment? Moment of 20, moment 20 about any point is 20. Okay, so the idea is if you have a line, so have a line like this, and there is a moment here. It's the 20. Okay, it's the 20. So this I can represent also as, I don't know, it is clockwise. We can also represent the moment as some, let's say 20 upward, 20 downward, 1 meter. So it's a couple. I can represent this moment as a couple. I can do that also. I can represent this as couple. So this both are same. നിങ്ങൾ കാണുന്നുണ്ടല്ലോ ഞാൻ എഴുതുന്നൊക്കെ?
Yes, sir.
So This is possible. Okay. Now, let's say we are putting it about the center. Okay. Now let's say this is 2 meter. This is 2 meter. This is 1 meter. Okay. We can do like that, or we can say this total distance is 1. This total distance is 2 meters. So that means this is half meter. This is half meter. Okay. Now, if you take moment about this point, this is my A point. Okay. This moment about A, summation of moment anti-clockwise. Okay. Now, 20 into, so what is this distance? This will become, so 2 minus 0.5 is 1.5. Okay. So 20 times 1.5, 20 times 1.5 plus, because it's clockwise, minus 20 times, so 1.5 plus 1 is 2.5. Okay, so that is 20 into 1.5 minus 2.5 equal to minus 20 into minus 1. Equal to minus 20 kilometer meter.
Hello, sir.
അൽത്താഫിന്
കേറാൻ പറ്റുന്നില്ല. അൽത്താഫ് ഹുസൈൻ
നെറ്റിന് എന്തെങ്കിലും പ്രശ്നമായിരിക്കും. നമുക്ക് ഒന്നും ചെയ്യാനില്ല.
നമുക്ക് ജോയിൻ ചെയ്യാൻ പറ്റുന്നില്ല. കുറെ നേരമായിട്ട് നോക്കുന്നുണ്ട്.
ഫോൺ ഒന്നും റീസ്റ്റാർട്ട് ചെയ്ത് ചെയ്യാൻ പറയും.
സർ.
Okay. So this is minus 20 kilometer meter. Okay. So that's why about this point also moment of this. So ഇത് രണ്ടും സെയിം ആണ്. അപ്പോൾ ഈ സിസ്റ്റത്തിന്റെ മൂവ്മെന്റ് കണ്ടുപിടിച്ചാൽ ഇതിന്റെ മൂവ്മെന്റ് കണ്ടുപിടിക്കുന്ന പോലെ തന്നെയാണ്. Okay. So moment about A due to this 20 is minus 20. So minus 20 because it is anti-clockwise direction. So minus 20. So if you take any point here, നിങ്ങൾ ഏത് പോയിന്റ് about മൂവ്മെന്റ് എടുത്തു കഴിഞ്ഞാൽ നിങ്ങൾക്ക് മൂവ്മെന്റിന്റെ ഇൻഫ്ലുവൻസ് സെയിം ആയിരിക്കും. Right? I hope that is clear. Now we will try to solve one more problem. So let's say we'll just complicate it a little bit. This is B. This is 1 meter. This is 2 meter. This is 1 meter. This is again. So this is 0.5 meter. And this is 1 meter. Okay, and height is 0.5 meter. Height is 0.5 meter. Okay, find the reaction. Reactions. Okay, so കാണുമ്പോൾ ഭയങ്കര കോംപ്ലിക്കേറ്റഡ് ആയിട്ട് തോന്നും. So there is a small beam here, simple supported beam here. അതിന്റെ മേലെ there is a bracket like this, 10 kilonewton. Okay, പിന്നെ there is again another bracket, 0.5 meter, 1.5 meter ആണ് ഇതിന്റെ height. ഇതിന്റെ 1 meter by 0.5 ആണ് ഇതിന്റെ height width. Okay, so I think I should reduce it here. Okay. Right, ഇവിടെ 20 kilonewton meter movement ആണ്, ഇവിടെ 10 kilonewton force ആണുള്ളത്. Okay, what you have to find the reactions. Okay, so first step you have to do is you have to just replace these two members by equivalent forces. ഈ രണ്ട് മെമ്പേഴ്സ് നിങ്ങൾ ഇക്വലന്റ് ഫോഴ്സ് ആയിട്ട് നിങ്ങൾ റീപ്ലേസ് ചെയ്യണം. അപ്പം ഇറ്റ് ഈസ് സിമ്പിളർ. നിങ്ങൾ ഒരു ബീമിൽ കുറച്ച് ലോഡ് ഉള്ള പോലെ നിങ്ങൾക്ക് കിട്ടും. ഓക്കെ, ഹൗ ഡു യു സോൾവ് ദിസ്? നിങ്ങളൊന്ന് ട്രൈ ചെയ്ത് നോക്കൂ. Find the equivalent force. So let's say what I need is so this I have to remove, and this also I have to remove. Okay, then I have to replace this by some force. I don't know, some force in vertical direction, some movement, and some horizontal force. This also I have to, I don't know, some force in horizontal direction, some vertical direction, some movement. I don't know. The values in here, you can tell me these values. So how do you do this? ഇതാണ് നമുക്ക് വേണ്ടത്. So these two should be same. First we'll take this. We'll take this structure. Okay. So this is my system 1. Take another copy. It's my system 2. So I'm replacing by, let's say, F5, Fx, yeah. So let's say I'll call this as, okay. So this is system 1, system 2. Okay. ഈ രണ്ട് സിസ്റ്റം സെയിം ആണ്. So അതുകൊണ്ട് we can always write summation of forces in x of this system should be equal to summation of forces in x. Okay, summation of forces in y of this should be equal to summation of forces in. അപ്പോൾ രണ്ട് സിസ്റ്റം ഈക്വലന്റ് ആവുന്ന അപ്പോഴാണ്. അപ്പോൾ രണ്ട് കോൺസെപ്റ്റ് ആണ് നമ്മളോട് യൂസ് ചെയ്യുന്നത്. ഒന്ന് ഇക്വലൻസി, അതായത് രണ്ടും സെയിം ആണെന്നുള്ളത്. രണ്ട് ഇക്വിലിബ്രിയം, അതായത് മൂവ് ചെയ്യുന്നിരുന്നത്. അത് റിയാക്ഷൻ കണ്ടുപിടിക്കാൻ ഇക്വിലിബ്രിയം യൂസ് ചെയ്യുന്നു. ഈ ലോഡിനെ ട്രാൻസ്ഫർ ചെയ്യാൻ ഇക്വലന്റ് കോൺസെപ്റ്റ് യൂസ് ചെയ്യുന്നു. ഓക്കെ, രണ്ട് കൺഫ്യൂസ് ആവരുത്. സമ്മേഷൻ ഓഫ് മൂവ്മെന്റ് അബൌട്ട് എനി പോയിന്റ് about, let's say we will take this point as O1, about O1 should be equal to summation of point about O1. Okay, now what is this? Then the values we will write. So Fx, x directionally the force will be 0. So x directionally we force in the, so that is, so this is again right positive, up positive, clockwise positive, same. Right positive, up positive, clockwise positive. The random or a convention. So this is Fx. Okay, so this implies Fx equal to 0. This random using Fx 0. Fy is minus 10. Fy is minus Fy. So this implies minus Fy equal to minus 10. So Fy equal to 10. So this is kilometer. Okay. Then moment about O1. Moment about O1 or about 10 into. So what is this distance? This distance is 1 meter. Okay. So that is 10 times 1. This is clockwise direction. So minus 10 times 1 equal to minus 10 kilometer. About this, Fy is passing through this point. Fx also is passing through the point. So random common moment is 0. M is anti-clockwise. So minus. Okay, so this random use what I'll get is minus m is equal to minus 10. So m equal to plus 10 kilometer. So I know what to replace these forces. This force in the y directional force 10 ആണ്. X directional force is 0 ആണ്. Moment എന്ന് പറയുമ്പോൾ clockwise ആണ്. നമ്മുടെ clockwise ആണ് നമ്മൾ assume ചെയ്യുന്നത്. So clockwise 10. Okay, മൂന്ന് ഫോഴ്സ് ഇവിടെയായി. ഇനി ഇത് same exercise we have to do for this also. So this is my system 1. So this I have to replace with another system. Okay. So let's say draw a line here. So let's say this is fy dash, fx dash, m dash. Okay. Let's do it again. Summation of forces in x direction. So you don't have to do this. Direct momentum force summation of force in x direction equal to, so right positive equal to 0. Summation of force in x direction equal to fx dash. So this random number equal, we'll get fx dash equal to 0. Okay, we are equating these two. Equivalent system means within the x direction of the force should be equal to within the x direction of the force. Okay, so that is very equating. So summation of forces in y direction up positive means, what is it? 0, because there is no force in up y direction. So that means summation of forces of this system in y direction equal to minus fy dash. This is equated, what we get? Fy dash equal to 0. In summation of moment about this point. So let's say I'll call this O2. This is O2. O2 equal to. So this is anti-clockwise moment, that is minus 20. Okay, there is no other moment. Summation of moment due to at O2 equal to. So there is fx dash not 0, fy dash not 0, because both of them pass to this point. M dash is minus m dash. This is minus m dash. Okay, so this gives me minus m dash is equal to minus 20. So m dash is equal to 20. So I hope that is clear. So fx dash 0, fy dash 0, m dash is 20 kilometer. We assume the direction 20 kilometer. So that we can assume as vertical force 0, horizontal force 0, moment is 20 kilometer meter. Okay, so now it is simple to solve. Simple and solve here. So now I'll remove all those unnecessary. So remove here. 0. 0. Okay. So now we can find reactions. Okay, reaction. We'll have two reactions here. Vertical, horizontal, vertical. Okay. Now equilibrium equations we use. Equilibrium. This system, it is not moving, translating in the right side direction. It is not moving in that direction. It is not rotating. Okay. So that means summation of all forces in x should be equal to 0. Summation of all forces in y should be equal to 0. And summation of moment about any point should be equal to 0. Okay. So let's say I'll start with moment now. Okay. Let's say summation of moment about a point. Let's say A, I'll take A equal to 0. So that means HA times 0 plus BA times 0 plus 10 times 1. It is trying to rotate in clockwise direction. E point it is trying to rotate in clockwise direction. So it is minus 10 times 1. Okay. Then this moment in the influence will be same moment clockwise. So it's minus 10. Okay. Then this moment is there. It is also clockwise. So it is minus 20. Okay, clockwise minus 20. Well, E moment in the influence of about this point. E moment due to this moment, the moment about this point will be same. But if it's clockwise direction, so minus. Within the minus. If it 10 into 1, clockwise around minus 10 into 1. Okay. Then VB. VB into, so what is the distance? This is 1. This is 2. This is 1. So 2, 3, 4. 11. 2, 3, 4. 4 meter. VB into 4. Plus VB into 4. Now, this is summation of movements about this should be equal to 0 because summation of moment about A should be equal to 0. Equilibrium. Okay. So this is gone, this is gone. So this is minus 10. There is another minus 10. There is another minus 20 plus 4 VB equal to 0. 4 VB. So 20, 30, 40 minus 40 plus 4 VB equal to 0. So that means VB equal to 40 by 4 equal to 10 kilometer. The VB value 10 kilometer. Okay. Now what about other values? So let's say summation of Fy equals 0. Fy equals 0. Up positive. So this is anti-clockwise positive. Okay, up positive. Up positive എന്ന് പറയുമ്പോൾ ഇവിടെ എത്രയുണ്ട് പ്ലസ് വി ആണ്. ഇങ്ങോട്ട് വരുമ്പോൾ മൈനസ് 10 അല്ലെ ഡൗൺവേർഡ് സോ മൈനസ് മൂവ്മെന്റ് കാരണം ഇറ്റ്സ് എ മൂവ്മെന്റ് നോട്ട് എ ഫോഴ്സ്. ഇറ്റ്സ് എ മൂവ്മെന്റ് നോട്ട് എ ഫോഴ്സ്. There is an upward VB. Okay, so what is the value of VA? VB is 10. So VA minus 10 plus 10 equal to 0. Okay, so there is some interesting phenomena happening here. So VB, so let's check. VB is 10. So 10 minus 10. So that means VA equal to 0. Okay. Now summation of forces in x direction should be equal to 0. X direction should be equal to 0. That is right positive. So we have HA. Is there any other horizontal force? There is no other horizontal force. So HA equals 0. So we have only one reaction. That's the reaction of the VB. These two reactions 0 ആണ്. ഈ മൂവ്മെന്റ് ഉള്ളത് കൊണ്ടാണ് സംഭവിക്കുന്നത്. Okay. So we can finally write the final answer. Final answer will be if you write VB equal to this value. So VB is 10, VA is 0, HA equals 0. Okay. And then we'll finalize it. Answer. Right. Any doubts here? Okay, then doubt you can ask me now. I hope it is clear. The steps you have to follow is simple. You have to shift this point to this. The load point complicated the more questions you do in simply supported, the more better it is. I would prefer simply supported being the questions. മുന്നോട്ട് നിങ്ങളുടെ ജീവിതത്തിൽ ഒരുപാട് യൂസ് ചെയ്യാൻ പോകുന്നതാണ് നിങ്ങൾ ഈ കോൺസെപ്റ്റുകൾ ഇങ്ങനെ ചെയ്യുന്നത്. ഓക്കെ, സോ ഇറ്റ് ഈസ് ഓൾവേസ് വെരി വെരി ഇമ്പോർട്ടൻറ്റ്. ഐ വിൽ ഗിവ് യു സം സെറ്റ് ഓഫ് ക്വസ്റ്റ്യൻസ്. Maybe I will give some points also for solving these questions. Now, there is another concept, very very important concept, uniform distributed load. Okay, so for example, consider we are building a house. So what we'll do, we'll use bricks. So common bricks. So then basically what you think is basically bricks. So okay. So let's say okay, something like that. Okay, so either you can see that let's say this is a semi-supported beam. Okay, ഇതിന്റെ എല്ലായിടത്തും ലോഡുണ്ട്. Okay, this is another phenomenon. നമ്മൾ വേറെ ഒന്ന് കമ്പയർ ചെയ്യണമെങ്കിൽ you can see let's say there is a small object here, sharp object. Okay, there is some force here or some big object over. Okay, so within the weight, it is coming on this point, only a single point. This is a point load. Point load. Okay, so this is a uniformly distributed load. Okay. There is another example. Let's say we have an aquarium. There is an aquarium to the ocean. Some container. Let's say we have a container. And we are filling it with water. Okay, and we are keeping this on a beam. This is about a beam rate. So this is water. Okay, so this also, if water the weight full, this is also uniformly distributed. Okay, so this is point load denoted. Point load is denoted by point load is denoted by a vertical line like this. Okay, this is how we denote point load. UDL, uniformly distributed load, we'll separate denote it some other way. Some other way. So that is, let's say, it is generally not like this. Or we can also distribute, mention that in some other way also. Easy tolerance. Okay, so I hope this is clear. About the load full light, line distribute. Okay, this is uniformly distributed. So this is representation of UDL. The UDL in the term you know this. So in the final year, point load. UDL. Point load of UDL. Okay. Now we have to study more about this. Now let's say we have a beam. We have a box here, some solid box. The box, it has some weight W. Okay, weight W. So let's say it has some weight. Weight W. Okay, and the length of the box is L. Length of the box. So this weight is placed in total length L. Okay, Now let's say I'm dividing this into small pieces. So let's say this is one piece, this is second piece, this is third piece, this is fourth piece, this is fifth piece. Okay, this is 5 pieces. So what is the weight of one piece? Let's say, what is the weight of this small piece? Let's say I give you small piece the weight. Somebody, what will be the weight of this piece? Anybody, can you tell me what will be the weight of this piece? Okay, so this I have divided into 1, 2, 3, 4, 5, 6. 6 pieces. 1, 2, 3, 4, 5, 6. So out of 6 pieces, what is the weight of one piece? What piece is the weight of it?
1 by 6.
Huh?
1 by
So
6.
weight is total W. So in terms of W, I need.
1 by 6. 1 by 6 of W.
1 by 6.
Of W. W by 6.
So W by 6. What about 2 pieces?
W by 3.
So 2 pieces is
W by 3.
So this is W by 6 into 2. Right? Now what about half of this piece? Let's say I take half of this piece. So let's say half of this piece. What will be weight of this half piece? Half piece.
W by 12.
W by 12. How did you find that?
W by 6 in the package.
So W by 6 is the total piece into half. Right? So this is how it is a piece now the idea is here is, so let's say if I want to if I have a small, if the total length is L and I want to find the weight of a small strip dx. So I want to find the weight of a small strip. Of dx width. How do you find it? Weight of the small. So let's say okay, I will just tell you. Tell me whether this makes sense or not. W by L into dx. Right now. Okay, because initially നമ്മുടെ L എന്ന് പറയുന്നത് 1, 2, 3, 4, 5. അപ്പോൾ ഈ ഒരു കേസ് ഞാൻ പറയാം. ഈ ഒരു കേസിൽ എൻ്റെ L എന്ന് പറയുന്ന 1, 2, L is equal to initial this കേസിൽ L equal to 1, 2, 3, 4, 5, 6. 6. Because this is 1 unit. Let's say this is 1 unit. Okay, so L is equal to 6. Okay, so how would I get this width for 1 unit? 1 unit in the W by L into 1. So that is W by 6 into 1. അതാണ് ഇത്. Right? Now what about 2? 2 എന്ന് പറയുമ്പോൾ W by L into 2. Because W by L എന്ന് പറയുമ്പോൾ it is same as W by 6 into 2. W by 6 ഇതാണ്. What I wanted is I want for 2 units. Okay. What about half units? This is half. ഇത് 1 ആണെങ്കിൽ ഇത് 2 ആണ്, ഇത് half ആണ്. Okay. So that means എൻ്റെ ഫോർമുല പ്രകാരം W by L into dx is 0.5. So W by 6 into half. ഇതാണ് ഇത്. Okay, so if you want to find length of a small strip, what you will do is total weight divided by L. Okay, so this total weight divided by L is UDL, and the unit is kilonewton per meter. So the total weight divided by the width, if you do, like total load divided by the length you do, you will get the UDL. അപ്പോൾ അതിനകത്ത് ഒരു ചെറിയ സ്ട്രിപ്പിന്റെ ഏരിയ വെയിറ്റ് നമ്മൾ അല്ലെങ്കിൽ ഫോഴ്സ് നമ്മൾ കണ്ടുപിടിക്കണമെങ്കിൽ W/L UDL into the width of the strip. I hope it is clear. എന്തൊരു സംശയം ഉണ്ടോ ഇതിൽ? അപ്പം നമ്മുടെ ഇനീഷ്യൽ കേസിൽ ഇത് ടോട്ടൽ ലെങ്ത് L6 ആണ്. സോ W/6 into ഇത് സിംഗിൾ DX-ന്റെ ലെങ്ത് ഞാൻ ആദ്യത്തെ കേസിൽ ഇവിടെ DX is equal to, ഈ കേസിൽ DX is equal to 1, ഈ കേസിൽ DX is equal to 2, ഈ കേസിൽ DX is equal to half. Okay, so W/6 L is equal to and L equal to 6. അപ്പോൾ W/L into dx, that is 1. W/L into dx, W/L into dx. Okay, so that is how we found different forces. So ഇത് ഞാൻ പറയാനുള്ള കാരണം എന്ന് വെച്ച് കഴിഞ്ഞാൽ നമുക്ക് ഇനി ജനറലൈസ് ചെയ്ത് വരുമ്പോൾ നമ്മുടെ ബീം ഇങ്ങനെയാണെങ്കിൽ beam is like this. So this is our beam. And we have a UDL like this. Okay. So this is W. So UDL W is in kilonewton per meter. Okay. So if you have to find the weight or force in this small region, what you will do is W into this weight. For example, if you have to use numbers, this concept of UDL is very important. Let's say this total, there is a UDL here. With a box in the weight UDL represent here. So let's say, okay, so this is, let's say this is 2 meters. This is again 2 meters. And this is 2 meters. And this UDL value is, let's say 10 kilonewton per meter. Bringing an UDL value there. Okay. So what is the total load? What is the total load on a 1 meter strip? 1 meter or meter. Let's say I'll take a 1 meter width here. One meter. Okay. So total force in 1 meter strip W/L into, so W/L is the UDL, 10, okay, into 1. So that means 10 times 10 kilo. Okay, അപ്പോൾ ഈ 10 എന്നുള്ളത് kilonewton per meter, 1 എന്നുള്ളത് മീറ്റർ. സോ kilonewton per meter into meter. ഓക്കെ, അപ്പം ഈ ഒരു UDL എന്ന് കഴിഞ്ഞാൽ UDL ഉണ്ടെങ്കിൽ UDLന്റെ ഒരു പെർട്ടിക്കുലർ ലെങ്തിലുള്ള ലെങ്ത് നമ്മൾ കണ്ടുപിടിക്കും. ഇനി ഈ കേസിൽ UDLിൽ നിന്ന് എങ്ങനെ നമുക്ക് ടോട്ടൽ വെയിറ്റ് കണ്ടുപിടിക്കാം? സിമ്പിൾ ആണ്. UDL കൊണ്ട് എങ്ങനെ ടോട്ടൽ ഫോഴ്സ് കണ്ടുപിടിക്കാം? ടോട്ടൽ ഫോഴ്സ് എങ്ങനെ കണ്ടുപിടിക്കാം? Total force is equal to W times UDL times length, equal to 10 times 2 equal to 20 kilonewton. Okay, but 20 kilonewton load ആണ് 2 meter spread ചെയ്തേക്കുന്നത്. അതിന് equivalent ആയി നോക്കി കഴിഞ്ഞാൽ 20 kilonewton weight ആണ് 2 meter length. അതാണ് 20 kilonewton ആണ് ഇതിന്റെ ടോട്ടൽ വെയിറ്റ്. അത് 2 meter കൊണ്ട് നമ്മൾ ഡിവൈഡ് ചെയ്ത്, അതായത് UDL കിട്ടുന്ന 20/2 ചെയ്ത് കഴിഞ്ഞാൽ UDL കിട്ടും. ടോട്ടൽ ലോഡ് കിട്ടുന്ന 10 into 2 ചെയ്ത് കഴിഞ്ഞാൽ 20. Okay, so total weight, total force due to a UDL is the value of the UDL times the total length of the UDL. Okay, so UDL we have to continue further. നമുക്ക് നാളെ ചെയ്യാം. So today, so let's say So I hope the concept of UDL is clear. So there is another representation also. UDL ഇങ്ങനെ represent ചെയ്യാറുണ്ട്. Okay, so this is my length. This is my length, and this is my something Q. Okay, so total load is, or total force is Q times. Okay, there are some more loads along with UDL. There is something called uniformly varying load. So it will be something like this. This is what is known as uniformly varying load. Right. Okay. So this load also is there. So we will see this also. Before that, we have to do some problems due to UDL. So UDL problem എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, so simplest problem that you can get is find the reaction. If the UDL is 20 km/meter, find the reaction. In negative problem, so this is 3 meters. 3 meters. Okay, അങ്ങനെയാണെങ്കിൽ എത്ര reactions? അങ്ങനത്തെ questions ആണ് വരാൻ സാധ്യതയുള്ളത്. So we will do more problem on this, but then I hope that UDL concept is more or less clear. Okay, so I think we should stop now.